Alright, we're now going to talk about inverse variation, and this behaves similarly, but instead of as y varies inversely, instead of being on top, if we see this, then this means that y equals k divided by x. We still use k, but when we see the word inversely, that means the second thing that we see goes on the bottom. And so we're going to look at some examples. Suppose that a varies inversely as b, so that means a equals k divided by b. Well, we know in this particular case that when a is 12 and b is 5, then we have a true statement. So in order for this to be true, we multiply both sides by 5, and we get k equals 60. Well, that means a is 60 divided by b, and so when b is 3, we get a equals 60 divided by 3, which is 20. So a is 20 when b is 3, because they vary inversely with each other. We've got one more example that I'd like to look at. Suppose that we have y varying inversely is the square root of x. So y equals k over the square root of x. And we know that y is 3/4 when x is 16. So 3 over 4 equals k over 4, which means k equals 3. So y equals k over the square root of x. Replace the k with a 3. In this case, we know that y is 2. So 2 equals 3 over the square root of x. Let's multiply both sides by the square root of x. So we get 2 square roots of x equals 3. Divide by 2. Square root of x equals 3/2. That means x is, when we square both sides, 9/4. So when y is 2, x is 9/4. And that's how we find our correct inverse variation pieces. Plug in the numbers and see how they work out.